Okay, great, great. So this is the home lab, Cozy, and hopefully you can all see my screen as well. This is my infrared camera. I was going to say later, but we're going to get started quickly now because with the presentation stuff. So we're going up the stairs. We're going to go into my office, which is not actually on fire, although it might look that way from the picture here. It's way too hot in this office. I have to turn off some of these computers. Let's see. How hot is it exactly? That's too hot. That's much too hot. That's a space heater, guys. Okay, so the topic of this is turning down structure nodes and switching to more efficient infrastructure nodes. Let me make sure I can actually get my slide. I think I had them here. We can see that now. Okay, so welcome to Cozy Summit 2025. I'm really excited to be here for a company called Navteca. And the goal of this talk is to my office. I've been a CozyStack user for a long time. One of the first contributors, joined the project, the Flux operator to CozyStack, because it seemed like a good fit, and it's fit pretty well. Some time now. Anyway, let's talk about who I am and what other credentials I have to be here. So I'm a maintainer, which is a graduated CNCF project that's part of CozyStack. I am a DevOps engineer called Navteca. I'm working on the cloud for NASA at Goddard Space Flight Center. I'm a home lab gremlin, which is primarily what we're going to talk about today. It would be very difficult for me, at least it's or even considered to do such a thing, to talk about for NASA. So what I've done instead, since we're not using CozyStack at NASA, we're going to talk about CozyStack and how I'm using it and why I'm using it in my home lab, in my free time. Actually, I have very simple needs. I have production needs so that there would be some kind of a stakes. My cluster is down, a website is down, someone might notice, that could impact my reputation somehow, but this is not an important website. Best for me to see what I can do on a Kubernetes cluster in a safe environment. Hopefully it's safe here. Hopefully it's safe. So I didn't enter, but you saw them hopefully in the video as well. The temperature in my office is at least 25 degrees hotter if you come with the door closed. So that's problem number one to solve. The joke was supposed to be that it's an infrared video. All right. What's currently in my home lab cluster at home? I have some workstation class machines, probably not the best Kubernetes cluster, and I could put a lot of RAM into them, which was the most important thing for me. I've already have a lot of machines sitting on the shelf. I'm tending towards fewer machines, and I also as for storage outside of the CozyStack cluster, and the reason for this will become apparent shortly. So I don't have a sophisticated way to measure energy usage. So I got an infrared camera so we could see some, and I've also got some little smart plug devices that I'm using so we can to try to understand what are our options and where are we spending the money. But I'm not going to recommend these because, and number two, I haven't figured out how to actually collect the data and put it in a graph as a metric yet. They have a that, but I've seen that there are some private API clients that may make this workable that are open source. So we're going to try that in the future, but that's still an aspirational goal. But having plugged the devices in, see nodes are, some of them are drawing more power, some are less. The single biggest thing that I've done is shutting off the test cluster. I had 2 Kuberneteses running in this cluster. So not familiar with the architecture, at the top level, you run Talos Linux on the bare metal, and then inside virtual machines, you can run control planes, you can run databases. All of these are packages, apps that are provided CozyStack platform. Now, I'm using virtual machines in a lot of different test applications, and what I like to tear my nodes down and stand them back up. Sometimes this is a thing that I do on a per node basis, as a procedure, but I've cut some corners here in my home lab, so it's a bit more complicated than the traditional CozyStack where everything is redundant. You can really take any at any time as long as it doesn't break the quorum, and it should be recovering quickly. And in fact, you can even ahead of taking a node so that those VMs are not impacted at all. But if quite some time for those services to come back, especially if you need to physically reboot the nodes. And there's called kubeovn plunger, you know. When you're rebooting the nodes, sometimes there can be issues that require an intervention. I think plunger is designed to solve that. So it is challenging to run Kubernetes in your home lab, that without a doubt. One of the things that's more feasible, more workable for me is to put all of my workloads that I'd really like quickly or to be high availability into WASM bundles. Now, WASM is an interesting technology that's well known, but not everyone understands what it's for. I'm calling it WASM and instructed and not WebAssembly, because when people hear WebAssembly, they get the wrong idea about what it's for. But WASM is for applications that run on servers. It's not necessarily a thing that runs in your web browser, although it's good at that too. It's good at workloads. Really, I'm saying 1 minute because I have a status monitor that does pings, and I do see a 15-minute blip when it's go down and come back up. So being able to run the WebAssembly workloads on CozyStack is kind of a key requirement for me. We've just heard a fellow who's building CozyStack for enterprise and for trees and how it's perfect and it meets all their needs. So now we're going to hear about how we actually a lot of things we'd still like to get out of the developer experiences, which is another cool story. One of the goals of this talk is to show assembly on a CozyStack cluster. And we're going to have to build our own Talos, and CozyStack is going to help. So I mentioned that I'm running multiple Kuberneteses on my cluster. If I had all in WASM, I wouldn't need any sub Kuberneteses, I think. Maybe. But if you're not familiar with how, there is a cluster API that runs controller, Kamaji runs control planes, runs virtual machine nodes that are the workers. So it's a real Kubernetes cluster. The only thing that's virtual about it worker node, but those are ephemeral. So they're cattle, not pets. They can be torn down and replaced at any time. The container storage top-level cluster is inherited, so you're able to attach and detach nodes. That's another thing, though. Attaching persistent volumes to your nodes is going to take a little bit longer to come back, since there are more dependencies and more things. We were able to turn off one of the Kuberneteses without creating any impact. Sometimes you do this when you're this is a home lab. I don't have real customers. I have friends who are building, and sometimes they help. I've built some things, CozyStack cluster, and those folks have moved on, and now I don't need that cluster anymore, so I can tear it down. Okay, so one of the things that I mentioned in the abstract for this talk that I would like to do, switch for, and I've been working on that diligently, and I have good news and bad news. One of the things that I wanted in this talk was how to ignore workloads, and we'll get to this close to the end. How to set on a node that doesn't exist. Say we've built a new cluster, and the cluster all consists of ARM64 nodes. We have a Redis operator, a MySQL operator, things that we won't use that we would like to remove from. Now, I think that there is a change in the works that will make this streamlined so that we can do this in a reasonable way. How to do this in a reasonable far. I've been doing things like this at my work job, where we actually ARM64 in a few places. We've switched a few clusters over using EKS, and it went extremely smoothly, which made me very optimistic. The abstract for this talk, I was very optimistic that this would all just work. Anyway, the idea, you want to shut down somewhere, install those Helm releases, or you could just, I mean, CozyStack is going to put them back. Their infrastructure. What I would like to do is find a way to patch a node selector into those workloads so that they don't run on my. And there might be a reason why we need to do this in the future as well. Like something doesn't support ARM64 yet. I am not 100% work on every. And in fact, I have a lot of Raspberry Pis at my house that are going unused. And one of the goals of this talk was to things into use. I want to treat this cluster like a production cluster and responsibly. So what I decided to actually do was to migrate to cloud. So it's kind of all over the place, right? We're talking about switching architectures, moving cluster to the cloud, but we have specific goals in mind, and we're trying to build with the AWS Graviton instances are bar none cheaper and faster, and if you can use them, they're not to. The CozyStack will work on those Graviton instances and keep our website online in the process. Most important thing, right? Then we can eventually move our cluster back to the home lab, more efficient instances that we have, potentially also save money by not paying for cloud resources, while we save energy by workload. I didn't want to build another Death Star. I'm already building a second Death Star here at home. I have Kubernetes at work and Kubernetes at home. Building another separate cluster seemed like a non-starter for me, unless I can do it without more heat. So I wanted to build this in the cloud. And I've been thinking about this transition for a while. So all that I care about at this point are already run in any architecture. So this simplifies things drastically for me. And this is a strategy that I recommend if you can work it. If you're building multi-arch container images, this adds a lot of complexity to your build pipeline. when I did this position was that the only workloads that weren't ready for ARM64 were that we had built ourselves. That all of the cloud native projects were really on top of this. They're already testing, they're already building multi-arch images, complexity. And so, well, I don't have the patience. I actually have a lot of other stuff to do. So if that's a step that I can just outright skip altogether, that's great. That succeed. And I've been following the changelogs. I've been Stack project for a while. But the CozyStack project is working on ARM64 support. So I wanted to test and see all of those things at once. Yeah. But the sad is, I think, and anyone in the chat, please correct me if I'm wrong. If you've tried to deploy CozyStack on ARM64, I'd love to hear. But I've tried this. I got the place where I actually it was in the install. So I think something in the installer for CozyStack itself needs worked so that it image. But I got very close. I got CozyStack extensions. We'll see how. But when I got to running the CozyStack installer, there's a component that was part that does leader election to make sure there's only one installer running at a time, and that appeared to not have capability. So okay, so we're going to fix this. Sure that this is fixed. I would really like to see Cozy on ARM64. I would like to see it running in the cloud, but I'm going to gloss over a lot of things. I have a repo full of notes coding this for a while, trying to understand what do we need to do to migrate to the cloud. And it's complicated. They're in the cloud and your home lab. You don't get a proper layer 2 network in the cloud. You get an ENI. It's a fixed address, and it's only allowed to use the address that it's assigned. And I think you can turn that off. I'm sure there's. As I started to build, try to understand what components I would need and translate things in a lift and shift way home lab into the cloud, I found that there were to come over. Like for example, Matchbox. Well, there's no TFTP boot in the cloud as far as I can. You use a cloud init file. So I do want to show how far I did get and find out about future progress. I want to show also the source for site, which site. I know you can build more elaborate things in Spin than this, but if you go to Erminac, you'll see this serves up very fast, and it redirects. And those are the key requirements for me, for my website, is I need to request it.com and redirect it to www.erminac.com or somewhere else. I have actually links in here filling out, but I haven't gotten around to it. Things like the video. I want you to be able to fetch that video. So I've had surprisingly few problems with this. Once I got it up and running, I know they had a rough start where I had to figure out running. SpinKube is the tool. And by the way, SpinKube was created by a company called Fermyon. It's another CNC open source, and Fermyon's just acquired by Akamai. So that's their company. So I have no insider information to offer, but I'm very excited to hear that. And that's going to be a good move for both companies. So we are running behind here. You can see that I have a time. So we're going to go in a little while. Try to reclaim some time here. But all of these are repos. Our almanac is fully open source. It was a grant-funded operation, and the grant development on this, but it's a great demo of how you can build a static website and do it with architecture. So let's actually pull up the source code. We will start here. This is where I have done most of the work on the CozyStack project. And in this place, I bootstrap and run my home lab. Many I've done this, but basically I've taken and absorbed the CozyStack installation instructions and replayed them over to the minimum amount of time that it requires to actually tear the entire cluster down to the studs, blank 0 drives, net boot, and get a new cluster running. And I think this is probably not the easiest to consume. For me, it works great, and you can see lots of videos of how I've done this over and over again on my YouTube channel. Let's talk. I built an AWS accounts repo where you can see the Terraform infrastructure. I've tried to make it best practices in here, but I didn't go full. So we've just got a few things in here. There are some modules, VPC, a Bastion host, private network in the cloud. That experience of building the home lab the CozyStack way, because part of the process involves putting Node. I'm sure that there's a correct cloud way to do this, but I wanted to keep it as close to the home lab experience as possible. And I wanted to have that. In fact, I built this network around the concept that it's only free thing. It was free anyway until December 1st. You could provision AWS Graviton nodes, cheap, free, as long as they're small and not 24/7. There's a day of T for no cost until the beginning of this month. We've also got, this is the big one, and back repo, which is where I have been vibe coding this whole architecture for home lab on ARM64 in the cloud, writing out requirements this in a way that's reproducible so that you all can actually take this and run it on your own. I don't recommend you do that. There are too many moving parts, too many assumptions that I've made that you'll need to have in your head in order to. I said, we're going to put some node in the cloud, which means that anyone who can get into the network can take them over. So all these details have really nailed down before we call it done. And there's some documentation. Lab architecture, the network. I have 2 subnets in my house where here is the netboot architecture that I described for DNS. Part is the registry cache. So I don't know if you all know this, but GitHub doesn't have IPv6 for any of their resources. So another part of this is the Bastion host has to proxy all the resources over IPv4, and actually is an opportunity for us because egress costs, and we don't want to download images over and over again for them every time. So the registry cache is a huge boon for us, and this I use in my home lab as well. One of the techniques that I use to make the restart time go down drastically because I had multiple bottlenecks in my home network. I eventually fixed those bottlenecks, but if you don't download something a second time when you don't need to, that's really the fix, right? So what are the other bullets that I have not hit? I wanted to make sure that I showed you how I'm using, and unfortunately, that's another thing I haven't been able to make work yet. And it's as far as Tailscale also does not support, or at least IPv6 only. It's trying to connect via IPv4. I've got via wire host to get out to the IPv4 internet. I did not want to set up a NAT gateway because, again, that's another thing that costs. Carefully here, cost plan, and I'm trying to keep the cost below like $4 for this whole experiment. I think today when we finally OCI Talos that we built, Talos image that let's talk about that. Let's GitHub workflow. So I have this build Talos images workflow. Basically what it does.
Sorry, we have just 2 minutes left, and I think you need to summarize your talk. And
yeah, okay.
So
okay, all right. So this workflow builds a Talos image from CozyStack upstream. It just uses the makefile. And it uses a couple of tools. It builds the image. You can see those images on the GitHub repo. And then we boot it using, well, we tried boot to Talos, but that one also didn't, unfortunately. So we're doing this finally using an ARM64 AMI, which we to our custom built CozyStack AMI. So we can get all the extensions that we need, all of the kernel extensions, all of the scale, spin, runtime modules, all of the extra things that CozyStack itself requires, and then our home lab experience. But unfortunately, I did hit some snags, and this is work in progress. There's still future work. I'm looking forward to continuing this work. And if you have for CozyStack, I hope that you will contact me and ask me questions. And indeed, I think we have at least a minute for questions. Let me check in on the chat. Oracle Cloud, always free machine, have CI on them. Actually, I'm using GitHub now off 64 runners. So that's, did I try iPixie with Talos on Raspberry Pis? I was able to get Kubernetes cluster running on Raspberry Pis, but I haven't, my goal was to get the cloud thing working first. There is a gotcha with net booting Raspberry Pis. Something like you have to have already an image that's capable. It needs, anyway, I was certain that I would run into more gotchas on the Raspberry nodes. I thought this might be a better trodden path. So far, it doesn't look that way. So thank you, everyone, for listening to my talk, and I appreciate your attention. I hope that you enjoy the rest of the conference today.
I think we have one more question.
Yep.
It's possible to have a hybrid approach using self-hosting as a primary cluster plus cloud hosting secondary.
Interested in trying that. I think data locality is the name of the game here. If you have, I was at KubeCon a few weeks. Thing that got me really excited was voice AI. And when I tried it on my own computer, I found if you're doing uncompressed audio, you really want to be generating that locally if you can. It's probably cheaper to download the entire model and then to just pay the bandwidth costs for uncompressed audio. So yeah, I think that's possible.
Okay, Thanks,
Thank you.
Kingdon, for such a great talk.